here in this line number 9, you can see that we are storing the value 10 in the variable A, we are storing the value 4 in the variable B, and we are trying to perform, we are trying to print right here, we are trying to print A and B. So what does this means? This is an bitwise AND operator. So we have seen normal AND operator, right? When in the comparison operators, we have seen this, but we have not seen the bitwise AND. The main difference between the normal AND and the bitwise AND is that the normal AND operates on conditions. That is, for example, if you take 2 less than 3, if you take 5 greater than 2, it operates on these conditions. Based on the truth table of the normal AND, it produces the corresponding outputs, right? So keeping this apart, whereas the bitwise AND tries to consider bits. It operates on bits. So here we are considering A. The binary representation of the A is 1010 because it is holding the value 10. And the binary representation of the 4 is 100, 0100. So you can check that. You can check by this procedure, right? 2, 4 and 2. And here remainder is 0 and 1. And here the remainder is 0. So 100. So this is the binary representation of the 4. That is 2 power 0, 2 power 1, 2 power 2. You are using 1 to power 2, that is 4. So this is the output, right? Here you can place any number of zeros because we are not considering all these values, right? 2 power 3, 2 power 4, we are not considering them, right? You can place any number of zeros. So we have placed a single zero. We have placed the single zero to balance the 4 digits, right? Here the 10 has 4 digits. Here the binary 4 has 3 digits. So we are trying to balance that. So we placed a 0 here. Nothing much more than that. So let's try to consider this. Let me clear the screen. Here we are trying to perform bitwise AND operator. This is the bitwise representation of the 10. This is bitwise representation of the 4. What does this undoes? We already know the truth table for the normal AND, right? We have already seen the truth table. This AND also operates in the same way, but the main difference is that here the bitwise 0 is considered as false and the bitwise 1 is considered as true. So that is the main difference. So they used conditions to check. Here we used 0 and 1s. If you have 0 here and if you have 0 here, which means false. If you have 1 here, if you have 0 here, which also means false. If you have 1 here, if you have 1 here, which means true. Because AND will become only true when both conditions are true. True means when both conditions are 1. And then if you have 0 here and if you have 1 here, then also you will have false. That is 0, 1, 0, 0. So this is the, so when you try to see, so this is the bitwise AND table. Same as AND table, but the main difference is that 0 is considered as false and 1 is considered as true. So this is how we do this. Let's try to check that. So here when you try to see, the first digit is 0 and this first digit is 0. So 0 and 0 both are false, right? As I said, 0 is false. Let me write it to make it clear. 1 is true. Here we can see that both are zeros, which means the output should be false. Here you can see the first one is true and the second one is false. For the you can write AND table, write AND table true and false, then the output would be false. And when you try to see this, the third one is 0 and this third one is 1. And false and true in AND table it is also false, so that's the reason we are getting 0 here. And when you take the fourth bit, the value is 1 and this fourth bit value is 0, and true and false the same case, that is false. So that's the reason we are getting 4 zeros. So what does this 4 zeros means? 2 power 0, 2 power 1, 2 power 2, 2 power 3 and so on, any number of zeros. Okay, so when you try to see this, the output would be 0, right? Because we are not considering any power value, so that's the reason the output is 0. So that's the reason when you execute the statement, when you perform the print statement between A and B, you are getting the value as 0. So this is how bitwise AND operator works. Let us try to see the OR operator. This is called bitwise OR operator. Please note that this is called bitwise OR operator. This is called bitwise operator. So the bitwise operator works same as OR operator, but in the same way, here 0 is considered as false and 1 is considered as true. And in the same operations, right? In the same OR operations, we have seen that, right? OR operator table. In the same way, we are trying to perform the bitwise operation. Let's keep this point here so that we are clear. 0 is false, 1 is true. So when you try to see here, the first value is 0. The first bit is 0, and here the first bit is 0. And 0 or 0, then the output is 0. So that's the reason we got 0 here. And when you try to see, the second bit is 1 and the second bit here is 0. 1 or 0, then the output would be 1, because OR operator except 0 and 0, everything is true, right? And then 0 and 1, the output would be 1. Here you can see that. And 1 and 0, obviously the output would be 1. So this is how the OR operator works. You can see the output, right? 14. How it is 14? Because 111, 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 3 you have to consider 18. 2 power 2 you have to consider 14, and 2 power 1 you have to consider 12. When you add them, you will get 14. So this is how we got 14 here. So that is the output. The next bitwise operator is negation operator, which is same as not operator. You have seen this not operator, right, in the comparison operators, which is same as not operator. So it is better to understand the negation operator in the form of decimals, because understanding this thing in binary is pretty difficult. So let us try to understand this in decimals so that we can understand this easily. Here in this line number 11, when you try to see negation of A, which is nothing but the output is minus 11, right? How it is minus 11? Because there is a simple formula, right? If you take an n as a number, then the negation of n would be minus of n plus 1. This is the simple formula. Here when you try to see negation of A, the answer would be A plus 1, that is minus of A plus 1. So the value that is stored in the A, in the previously we can see in that, right? We have assigned the A with the value 10. So the value 10 is present in the A. So when you try to perform the negation of A, as per the formula, when you perform negation of 10, you will get minus of 10 plus 1. So this is the answer, right? So that's the reason we got the minus 11 here. So this is how negation operator works. Let us try to see two more operators. This is bitwise right shift operator and this is bitwise left shift operator. Let us try to see how these operators works. So here also let us try to understand this thing in decimals, because understanding this thing in decimals is pretty easier than understanding it in binary. Let me tell you how these operators works. Here in this line number 12, we can see that we are printing this value, right? Let us try to understand how this value works. Let me write the value here. Here when you try to observe, you have two values, right? What does this two value means? Here the first value indicates the value on which you want to perform the right shift, and the second value indicates how many times you want to perform. So that is the main difference. This is the value which indicates on which value that you want to perform the right shift. Here this value indicates how many times you want to perform the right shift. This is called right shift because the arrow heads are pointing towards the right side, right? So this is called right shift operator, nothing much more than that. Let us try to see how the right shift operator works. Here we are trying to right shift 3 times, right? So the first time when you perform right shift, what we will do is that we will divide the value by 2. The quotient, we will only consider the integer quotient part. If you remind the floor division, what we will do, we will take the floor value, that is integer part value, nothing but it is also called as integer division, right? If you remember that. So we are trying to perform integer division here. So when you try to perform 10 by 2, you will get the quotient as 5. And then when you try to perform 5 by 2, you will get the quotient as 2.5, right? But we will only consider 2. And then we will divide the 2 by 2. And then the final output would be 1. So that's the reason we are getting the 1. Then there is a question, why are we performing this division? So right shift operator is nothing but dividing the value by 2 and then taking the value and dividing it again by 2 until the number of times is completed. Here the first time is completed, here the second time is completed, and here the third time is completed. So the value obtained by performing 3 right shifts is 1. So this is how we perform right shift operator. To understand this thing in binary, it is nothing but if you consider 10, right? 1 0 1 0. If you consider 10 in binary, it would be like this, right? If you want to perform right shift, then what we will do is that we will shift the digits by 1 position towards the right side. So when you try to perform right shift, what will happen? This 1 will go here, this 0 will come here, and this 1 will come here. Then the output would be somewhat like 1 0 1, right? 2 power z 0, 2 power 1, 2 power 2. We won't consider this right side part. Once it goes towards this side, we won't consider anything because it is beyond the 2 power 0, that is 0, right? So we won't consider these values. So the first time when you try to perform right shift, you will get 1 0 1. You can check that 1 0 1 means 4 plus 2 power 0 means 1. So 5. So this is what we got, right? 5. And then when you try to perform right shift again, what will be the value? This 1 will go to the right, this 0 will come here, this 1 will come here. Then the value would be 1 0, right? When you try to check what is 1 0, it is 2, right? Because only 1 at the position, only 1 at the 2 power 1 position, which means the value is 2. So that here we got 2, right? And when you try to perform right shift on this operator, what will happen? 2 power 1 right shift when you try to perform 2 power 1, 2 power 0, and the value 1 will be present here and nothing will be present here, anything zeros. So when you try to check, well, you have only 1 at the value 2 power 0, which means you are considering 2 power 0, that is 1. So these 3 times we have performed the right shift, right? This is the first time, this is the second time, and this is the third time. And the 3 times right shift is completed. So what will be the output? 1. So this is how we try to perform the right shift in the bits. But it is easy to understand in decimal, right? So keep the decimal thing in mind. So this is how we try to perform right shift. Left shift is quite opposite to it. We will multiply. Here we try to divide, right? Here we try to multiply. When you try to perform left shift on the 3 times, what we will do is that first time we will multiply it by 2. that is 10. Second time we will multiply with the 10 value into 2, that is 20. And the third time we multiply the 20 value into 2, that is 40. So the output would be 40. So this is how we perform the left shift operator. So these are the bitwise operator that we need to know.